This video is sponsored by Sketchfab. Using instances with geometry nodes is really useful for scattering a bunch of objects around, and we have a lot of options to work with when doing this. Here's a summary of what I'll cover in this video. I'll start with talking about what instances are and how we used them before geometry nodes. Then I'll show you how to instance objects onto the points of a mesh, then onto the faces of a mesh. I'll show how to scatter collections of objects, other ways of distributing points in a more random way, and also how to randomize rotation and scale. I'll use weight painting to control where things get scattered, and then I'll talk about the concept of realizing instances. I'll cover how materials work with instances, and I'll end with making this cool fractal shape using node groups. If you're a complete beginner with geometry nodes, you should probably watch this video first. Also check my Patreon for the project files from my videos, coupon codes for free products, early access videos, and stuff I don't share anywhere else. I also donate a portion of the profits to environmental causes each month. Links for everything are in the description. Alright, let's get started. So here we are in Blender. I'm using version 3.1 for this one, and I recommend using 3.1 or later. If you're using maybe an early build of 3.1, you might need to update. And if you're using something a little older, then some of these nodes might not exist, or they might have different names, so make sure you're staying up to date. First, let's talk about how to use instances without geometry nodes. So I'll just add in an icosphere with Shift-A, icosphere. And what I want to do is instance a shape onto each point of this icosphere. So we need to add in a second shape. I'll add in a cone right here. And I'm just going to drag it to the side. And in edit mode, I'm just going to move it up by 1 meter so that the origin is at the bottom like that. This will just make it sit a little more nicely on the points. Now I'll select the icosphere, and if we go over to Object Properties and scroll down, we have this option called Instancing right here. And if we click on these other buttons, nothing is really going to happen because this only works when there are things parented to the object. So we can parent the cone to the icosphere. I'll just select the cone and Shift select the icosphere, Control P, and set parent to object like that. So now you can see that the cone is on each point. It's kind of big, so I'll just select the cone and scale that down. And when we select the icosphere, you can see we have it set to instance on each vertex. And we also have this button aligned to vertex normal like that. And this will change the rotation of each instance depending on, how the object is shaped. So in case you didn't get it yet, instances are kind of like copies of objects. And the reason it makes sense to use instances instead of just duplicating the same object like over and over again is because it's actually a lot faster to use instances compared to the other method. It just doesn't have to compute things in the same way because you're using like a bunch of copies. Also, if you're not sure what normals are, let's just turn this off for now. You can actually visualize the normals by selecting your object, going into edit mode, and up here under overlays, scroll to the very bottom, you have normals right here. So this first one is vertex normals. You can just turn the size up a little. You can see that there's a line kind of sticking out from every point, and this is the normal direction. It's basically going to stick out perpendicular to each vertex. And we can also turn on face normals too, which is basically the same thing, except it's in the middle of each face like that. So this is the normal direction, and it's important to understand what the normal direction is because you have a lot of options that have to do with utilizing the normal direction. So let's turn this off for now and look at this other option, faces. So this is basically going to do the same thing as vertices, except, it's instancing on the middle of the face instead. And this is going to point out in the normal direction by default. We also have scale by face size, which lets you, scale things around. And this makes a little more sense when you actually go into edit mode and start adjusting the face sizes. So if we scale this face down, you can see that, the instance on it will also get smaller, like that. So this is instancing without geometry nodes, and there are some limitations to this. Like if you wanted to instance a whole bunch of different objects other than just a cone, you can't really do that with this method. That's something you would have to do with particles maybe. So you could go to particles and add a new particle system. But there are limitations to this also, like it doesn't use nodes. So I talked in my last video about the benefit of node-based systems. Using the particle system is a completely separate topic. So I'm not going to cover that too much. But one thing to note is that the particle system right now, at the time of recording anyway, does have some features that that geometry nodes still doesn't have. Like for instance, this emitter, if we press play, you can see it's emitting a bunch of points like this. It's kind of using physics. Geometry nodes can't do that yet, but it might be able to do that in the future. I believe at some point it will gain all of these features also, but with the benefit of it using nodes. That's something to keep in mind. Now let's get rid of that. And I'm also going to, make the cone not parented anymore. So Alt-P to clear that, and I'll move it to the side. I'll hit Alt-S to reset the scale. And I'm going to replace this with a fresh new icosphere, and we'll go into geometry nodes. So up here, you can go into the geometry nodes workspace. And if you don't see that, once again, go to General, and it's under there, like that. So now that we're in here, I'm just going to select that icosphere and click New to add a new geometry nodes tree. You can see it added the modifier also. And I'm going to click this so that we can have all of these snap to the grid. So let's talk about instancing onto points with geometry nodes. So if we hit Shift-A, under instances, we have instance on points right here. We also have these other options that we'll talk about a little later, but we're going to start with instance on points. So let's just look at this node. We have points in here. So these are the points that we want to instance on. And then we have instance right here, which is, whatever shape we want. So we can drop this in right here and it will connect to the points automatically, but we don't have an instance shape yet. So we need to bring one in here. So you can hit Shift-A. And under input, we have object info. So you can use this and select whatever object you want in here. But there is another way also. You can just go up to the outliner and you can click and drag your object and just drag it into here. So this is the cone that we were using before. We can drag the geometry onto the instance like that. And we might want to just scale this down. So we have this scale option right here. You can select all of them like that and just drag it down. I like to hold shift when I'm dragging to make it change slower. So we have a cone on each point right now, but we don't have our original mesh. So like I showed in the last video, you just need to use a join geometry node. So you can hit Shift-A, under geometry, join geometry, and just join it with the original mesh right here. If we have the object info set to original, it's going to kind of treat this like it's in the center of the world like that. If we have it set to relative, it will pay attention to like the scale and where it is in the world over here like that. So I almost always just have it set to original. If we want these to stick out in the normal direction, we have to change the rotation right here. And what we need to plug in here is the normal value. So we can hit Shift-A. This is under input, normal, like that. So we can't really plug this in directly, or we can, but it doesn't give us the effect that we're looking for. We need to use this other node called Align Euler to Vector. So Shift-A, and then under Utilities, Align Euler to Vector right here. You just want to plug the normal into the vector, and then plug the rotation into the rotation. And it might not be obvious, but this is actually doing what we want. It's just using the wrong axis. So if we change this to the Z axis, it will point straight out like that. Like I said in my last video, I am using the Node Wrangler add-on. With the Node Wrangler add-on, if you hold Shift and right click and drag, you can add this reroute node. So I'm just going to do that really quick. And I'm going to add in another node called the subdivision surface node. So Shift-A, I'm going to search for subdivision surface right here, and I'm just going to drop it in. If we scale this down, we can see it's adding more faces like that. But as we subdivide and add more points, you can see that the size of each instanced shape is staying the same. It's not really adapting to the face size. So one way to change that is by checking the face size. So there's a node for that, Shift-A, I believe that's under Mesh, Face Area right here. And we can plug that into the scale right there. And this is already kind of doing what we want, but as we turn it up, you can see that the instances kind of get smaller than we want. So we need another node in here. So just get a math node and plug it in right here. And the one we want to set this to is square root, and this will make it scale consistently. But as you can see, this is like pretty big right now. So if we wanted to control the size of this, usually what I do is just use another math node set to multiply. You can put it afterward, and you can use this to control the size. So now as we add subdivisions, you can see that these will kind of scale down accordingly. There are a few other ways to scale instances. So instead of using a multiply node, you could also edit the object directly with like a transform node. So you could use a transform node and drop it in right here and affect the scale this way. There's also under instances, a scale instances node right here. So you just want to place this after the instance on points where we have all the instances like this. And you can scale that however you want also. Under there, you can see we also have rotate instances and translate instances. I'll talk more about rotating a little later. But we also have a node called scale elements. And this works for, things that aren't instances also. This works a little differently because instead of scaling based on the origin point, the pivot point right here, it will scale from like the center of the mesh. So you can see as we scale this down, they kind of start floating because the center point is not at the bottom. So that's something to keep in mind if you're using the scale elements node, which we're not really going to use in this video. So next I'll show you how to instance onto faces instead of onto points. I'm just going to create a new node tree for that. I'll just name this vertices and make a new one right here and call this faces. So now I have two different node trees. I'm just going to save all of these separately. So before I instance these onto the faces, I'm just going to remove the rotation and the scale, and I'll explain why a little later. So to instance onto faces, we still want to instance on points, but we need to change where the points are. So under mesh, we have mesh to points right here. And you can see by default, it takes a mesh and it outputs points right here, and it's set to vertices by default. So if we plug it in right here, we can preview it with Alt Shift and left click. Once again, I believe this is a Node Wrangler thing, so make sure you have Node Wrangler installed. This is turning each vertex into a point, and we have a few options. So we could use, edges or faces or corners. We're going to use faces. So let's look at our original geometry again. You can see now all of the instances are in the center of each face now, compared to where they were before. But now if we plug the rotation in, it's not going to work correctly, and the face area is also not going to work correctly. And the reason for this has to do with how fields work. If you want to learn more about fields, I put a link to the documentation in the description. But basically, normal and face area are fields, and these are going to do different things depending on where you plug them in. So face area, for example, if I plug it into here, the face area node is going to pay attention to where you plug it in and try to figure out what geometry is going into this node right here. So if we see what geometry is going into here, the last node is this mesh to points, and if we look at that, it has no faces, it's just a bunch of points. So it has no faces to reference, so that's why it's not working. Same thing with the normal. It's also looking at this node right here, and it doesn't know how to calculate the normals. So what we want to do is find the face area before this node right here, which is just our normal mesh right there. And to do that, we need a node called the capture attribute node. So I'll hit Shift A at the very top, attribute. We have capture attribute right here. And this is how you can get field values from specific points in your tree right here. So I'll just drop this in right here, and on its own it doesn't do anything, it's just kind of grabbing a value. And I'm going to use this for the normal, so I'll bring the normal over, and we just need to change this from float to vector so that the socket color is the same. And then instead of using this normal, we can use the attribute right here. Just plug that in to the vector of this align Euler to vector, and then plug that into the rotation. And now this is working properly because it's checking the normals, as it looks like this instead of, at this point right here. Hopefully that makes sense. We can also do the same thing for the face area. Just grab another capture attribute, Shift D to duplicate, and we'll change this from vector to float because that's what we're getting from face area. Can plug that in here and do the same thing. We'll just drag the attribute down into the square root and plug that into the scale. And now we have all of the same options that we had before. If I add some subdivisions, these will scale down accordingly. So it can be kind of a hassle to set up the first time, but once you understand it, it gets pretty easy. But being able to use these is actually pretty powerful. You can actually do a lot of cool stuff. Like if you check out some of my other geometry node videos, I actually use them a lot. Let's talk about random transformation now, so like scaling and rotating. For that, I'm going to create a new node tree. Instead of using the geometry input, I'm going to replace that with a grid. So Shift A, add a grid. You can plug that in right here. And I'll just change this to something a little higher, like 20. I also want to replace this cone with a cube. So you can either add a cube in here, Shift A and search for a cube, but I'm actually going to add a cube in here just like I did with the cone. So I'll add a cube and I'll move it up in edit mode once again so that the origin point is at the bottom. And we can just turn this to a cube right there. So here we have it. So if I wanted to, I could actually scale each of these instances randomly using this node right here, the scale instances. Basically, anytime you have a diamond socket like that, you can plug in a random value or a texture or something like that. Oh yeah, and another way that you can search for nodes is by just dragging. You see this plus right here. You just let go and it will come up with like a search menu. So I'll just search for random value like that. It gives us this random value set to vector. So this is going to scale it on differently on each axis. If you wanted this to just scale up and down uniformly, you could just change this to float, and you just need to plug it back in to the scale right here. And now it's giving each of these instances a random value between 0 and 1 like that. So you can adjust the range if you want. If you wanted this to scale only on one axis, just like I showed in my last video, you could just use a combine XYZ like that. And all of these disappear because they're set to 0, and by default you can see the scale is set to 1. So just make sure that you're resetting these to 1 if you want it to look the same. I'll just plug the random value into the Z socket like that. And I'll set the minimum to 1 and the max to something a little higher. So this is how you could randomize the scale on just one axis like this. And you can see it's a pretty cool effect. This almost looks like a city. So you could use this to create like a simple city generator, something like that. Let's do the same thing, but for rotation. So Shift A, under instances, we have rotate instances. If you want to move things randomly, under instances, we have translate instances like that. And this works the same way that we're using these two nodes right here. So I'm not really going to explain this because it should be self-explanatory if you know how to use these two. But you can use this to rotate things like that. And also, if you want this to only use one axis, then you can just bring a combine XYZ in here the same way. I'll just turn all of these to 0. And we can use a random value node right here. The rotation by default is in degrees right here, but as soon as you use a combine XYZ, it's not using degrees anymore. It's a little confusing, but instead of using degrees, this is using something called radians. It's a different way of measuring rotation. So if you wanted this to rotate a full 360 degrees, that would be pi times 2. You can just type in pi times 2. That's also called tau, T-A-U. It's the same number. And if you don't want to use radians, so you'd rather use degrees, you can just bring in a math node right here and set this to 2 radians. If we plug this into here, we can put in degrees and it outputs radians. So if we want, we can rotate all of these 45 degrees, just type in 45, and you don't have to think about how to convert it to radians. So now let's just plug in this random value node right here to the Z. If you want, you can use the 2 radians right here, plug that into the maximum. And so we can make it so each of these has a random rotation between 0 and 360 degrees. So these will look quite a bit more random now like that. Let's also talk about collection instancing, because right now we're only using one shape. One of the cool things you can do with geometry nodes is instance, scatter multiple different shapes. So instead of using the object info node, we could hit Shift A. Under input, we have collection info right here. So we can use all of the objects from any of these collections. Let's actually create a new collection. So hover over here and hit C. That'll create a new collection. And I want both of these shapes to be in that collection. So you can select them and either drag them in like that, or you can hit M in your viewport, and that will move it to collection 3. I'll just name this something like instances. And I want some more variety, so I'll add another shape in here. I'll add an icosphere, and I'll move that up 1 meter in edit mode, just like the other ones. Let's add a 4th one, actually. We'll add a cylinder. So just make sure all of these objects are in this collection right here, and we can just hide the collection like that. So you can either select that collection in here, or just like how we did with the object, you can just drag entire collections in like that, okay? And we can just plug this in to the instances right here. So right now it's taking the entire collection, all of these shapes, and instancing them onto each vertex. So we can select separate children and pick instance, and now we're limited to just one shape per point like that. And if we hit reset children, it'll actually snap to the points like that. So what reset children is actually doing is kind of treating each of these shapes as if they're in the center of the world like that, instead of off to the side where I have them. But if you don't have reset children, when you move this around, you can see I moved the cone from where it was, and it's actually going to be in a different spot over here also. So I almost always reset the children. So I'm just gonna mute these two right here. You can just select them and hit M to mute. If we look at this from the top, this is actually distributed in a very regular way. And the way this is organized is kind of looking at the index value of each vertex. And it's also paying attention to like the order they appear over here in the outliner. We can actually test this out if we use this instance index option right here. We can just use an integer. And I know it's an integer because it's the same color right here, that green color. So this is how we can select a specific object from a collection. When you're using index values, the first value is always 0 instead of 1, so they're going to be offset a little. But the first value, or 0, is going to be a cone, and I know that because it's the first over here in the outliner. Second should be cube, and then cylinder, and then icosphere. So we have cube, just like over here, cylinder, and then icosphere, like that. And if you go higher, it'll actually just keep going in the same order, but just like starting from the beginning, it just loops back to the beginning. This also works for negative numbers too. And this is actually nice because if you're trying to randomize it, which we can also do. So I'll just separate this and grab a random value right here. By default, if you're using this set to an integer, the maximum value is 100. So we don't actually have to know how many objects are in here for this to work properly. We don't have to set this to like 3 or whatever. We have something that looks quite a bit more random. And if you don't like the order that they're put down, you can just change the seed right here and it will just kind of, it'll just randomize them again. Let's take a break to talk about the sponsor, Sketchfab. Sketchfab is an online marketplace where you can buy and sell 3D models. They have more than 3 million models to choose from, and deciding which models you want to download is actually pretty fun because you can inspect them in the browser to see them from any angle and check out the materials and geometry. Sketchfab also has importer add-ons that make it really easy to get models into your projects. So if you're looking for assets to fill your scenes, check out Sketchfab. It really is a great resource. All right, let's talk about another way to distribute points. So even though there's like a random object on each point, it's still on each point, so these are like in a grid. If you wanted points scattered more randomly, you can use a distribute points on faces, which is under point, distribute points on faces right here. So I'll keep using the grid, and I'm just going to place this node right here, right before the instance on points. So if we take a look at this with Alt, Shift, and left click, this is what it's doing. It's kind of replacing the mesh with a bunch of points. And when you turn the density up, it's just going to, add more points like that. And you can change the seed to place them in a different like random location like that. We also have this other option called Poisson Disk. And if we select that, it's initially going to seem kind of the same, except you also have this distance minimum option right here. And what this does, let's look from the top. What this does is it will keep the points a certain distance apart from each other. So we could turn this up a little higher to like 0.1. So now all of these points will always be 0.1 meters from each other or more. And this is a diameter, so it's kind of like drawing a circle around it, and the width of the circle is 0.1 meters. Even if we turn the density up super high, you can see none of these will be touching each other, which is pretty nice for if you're scattering objects and you don't want any of them to be intersecting. We also have this density factor, which just goes from 0 to 1. And you can just, turn that up and down to kind of like turn the points on and off like that. So we're still using a collection over here. I'm just going to plug everything back in, and I'm going to remove the normal and the scale like that, because that's we're running into the same issue basically that we had when we were instancing on the faces. It's being replaced with points, so we don't have faces, and it's not tracking the normal in the same way. So I'll just get rid of these. So to explain this distance minimum a little further, I'll just bring in a cylinder. And I'm using a cylinder because this uses a radius and the distance minimum is a diameter. So a radius is always going to be, you know, half the length of a diameter. So we just need to make sure, instead of the radius and the distance minimum being the same, we just want to make sure that the radius is half. So we can make it 0.05 like that. Now we can just replace the collection with this and turn off pick instance. Make sure that scale is set to 1. I'm just going to turn this down quite a bit. And we can look from the top. And none of these should be touching, even if we turn the density up really high. If you're using a shape like a cube instead, you're going to have to measure this a little differently. So I'll set this to 0.1, but these will overlap in some spots. That's because these values right here are measuring like the width and the length and all that. The diagonal values are actually going to be greater than 0.1, so you would have to turn this up a little for them to not intersect in the same way. That's just something to keep in mind. So one nice thing about this node is it gives us the normal and the rotation from you know, the mesh that's being plugged in. So if we were using a different shape, so I'll bring in like an icosphere. If we're using a different shape like this, instead of doing the capture attribute trick like we did before, you can just plug the rotation directly into the rotation like that, and it will stick out properly, you know, as if you were doing it the same way, which is really convenient. Now let's talk about how to distribute points, but with vertex groups. So if you're going to use vertex groups, you have to use the input geometry right here. Otherwise, it's not going to work. Using vertex groups is really nice for, say, if you have like a big plane and you want to scatter a bunch of rocks or trees or something, but you want them to be in very deliberate spots, you can kind of paint it on with weight painting. So to get started, if we're using a distribute points on faces, we could use the density factor right here. And you want to make sure that you're using something that has a diamond socket. So we can grab this empty spot from the group input and just drag that over to density factor. Now we have that over here on our modifier to control, and there is this extra button right here. So if we click that, it'll let us input all of these different things right here, and we want to put in a vertex group, but right now we don't have any vertex groups, so we need to add one. So we can go over here to Object Data Properties, where we have vertex groups. You can add one and you can name it whatever you want. I'll just name it scatter. Now if we go back to the modifiers and check this out, we actually have something called scatter. This will be whatever you named it. So we can click on that. Now if we go back over to the vertex groups, we can actually you know, decide where we want to place this. So this is going to be based on the geometry. So you can tab into edit mode over here, and we'll have these other options, assign, remove, and we have this weight right here. So we can select some of these points right there and hit assign. It's going to assign this weight to all of these points we have selected. When we do that, you can see now that points are distributed there. So let's just hit Control Z to undo this. And I'm going to increase the resolution by hitting right click and subdividing a few times right here. I'll turn the smoothness up a little. So now we have more points to work with, and we can get more specific shapes if we want. Another thing you can do is change the weight. So if you want it to be half as dense, you can just turn this to something like 0.5 and then select some points and assign. And this should be half as dense. It's basically like if you set the density factor to 0.5 in that spot. So instead of putting it in this way, you can also use weight painting. So you can go up here over to weight paint, and this is going to work the same way. You want to make sure that you have the correct vertex group selected, and you can just start painting where you want your objects to be. And if you want it to be a different weight, you would just select that up here. Lighter like that, and now, you know, they're not as close over here. So there are a few different ways of doing this. All of them require, you know, using a group input and making sure that you plug it into a diamond right there. So let's change this to random right here. And you can see we have fewer options. We could plug it into the density, which has a diamond right there. So let's try that. We're limited to this weight right here, which only goes up to 1. And that's the equivalent of having our density set to 1 right there, which is very sparse. There aren't that many objects. So we can change this a few different ways. We could add a math node in here and just set that to multiply and just turn this up to however high we want to control like the maximum density like that. Map range and change the to max This is pretty much the same thing as using a multiply node, or you could use something like a mix RGB and plug the density factor into the factor right here. And then you can use these two slots as your minimum and maximum values. So you can either just type the numbers you want right into the value right here. So I'll just type like 100, or you can use value nodes like this and plug these into the color slots and set these to be whatever you want. Now, if we wanted to, we could also use Vertex Groups to control things like the scale of these. So let's do that. I'll just plug the combine XYZ over into the scale right here. We're going to have to turn this down quite a bit, 0.03. And I'm going to use a multiply add node. I'll set the add to 0.03 and plug this in right here. And we can adjust these values however we see fit. But first, let's take one of these empty slots from the group input, and we'll plug it into the value of this node right here. And now we have this over here, and we can set this to have a different vertex group. We'll just add a second one, and I'll name it scale. And we'll click this button and make sure we add scale. Now, just when you're in weight paint, you want to make sure that you have the right vertex group selected. So right now, all the points should be set to 0. So let's just like paint some of these in, and it's changing the scale. We can change the, the maximum value with this multiplier right here. So we can just turn it up like a little bit like that. And this would be useful for creating like tall patches of grasses or things like that. I'm sure you can think of a lot of different ways to use this. So let's talk about realizing instances and when you should do it. So if we hit Shift A under instances, we have this other node, realize instances. Basically what this does is it makes the geometry nodes stop treating instances like they're actually copies and treating them like they're like original objects. And this allows you to control like individual points from each of the instances and things like that. So to explain this, let's use a set position node. And this is basically the equivalent of using a displacement modifier right here, displace. It allows you to move each point and stuff. So let's control this with a texture. I'll use a noise texture, and I'll just set this up pretty quickly with a math node set to multiply to control the strength. And I want this to only be going up and down, so we also need a combine XYZ right here. And I'll plug this into the Z like that. So right now, each of these cubes is not realized. And when we set the position with this noise texture, you can see they're just floating up and down. It's kind of treating each cube like it's a single point almost, and not deforming this. As soon as we put the realized instances in here, it'll start deforming each individual point like that. And you can see all of these are very warped now. Whereas right here, each cube is completely intact like normal. Another thing that happens when you realize instances is it treats materials a little differently. So let's add a material. We'll add in a set material node. And again, I talked about setting materials in the first video. So you can just drop that in right here. We need to create a material over on the side. I'll just name this something like instance, and we can use that material right here. So let's go over to shading now. And I'll set something up quickly. I'll just use a Voronoi texture right here. Hit Control T to add these two nodes with the node wrangler. I'm going to use the object texture coordinates, and I'll plug the color in right here. Right now in our geometry nodes, this is not realized. And if we turn the scale of this down, you can see that each cube actually has the same exact texture right here. It's all appearing in like the same spot like that, even though they're in different spots right here. And if we go back over to the geometry nodes, when we move this around, the texture sticks to each cube. As soon as we realize it, it's gonna stop treating each of them like a copy. And you can see it's applying the material as if it's like a single object. You can see when I move this up and down like that, the texture will actually change depending on where it is. So that's something you have to think about too when you're realizing instances. If you wanted the texture to stick to each cube like this, but actually look a little different, you can do that. Just go over to shading. In the shading area, there is a node I'm going to search for called object info right here. You can see it will give us information about each object. And one nice thing about this node is that it treats instances like they're separate objects. So we actually have, a different location for each instance. We also have this random value. It'll give us a random value between 0 and 1 per instance like that. So we can use this to to make this look a little different. If we wanted, we could plug the random into the location of the mapping right here. So now each object will have a random location between 0 and 1, so these will look a little more different. We could also change this to like 4D and plug the random into the W right here. And if this isn't random enough for you, you can do a few things. You could add in a math node set to multiply and multiply it by like a really big number, like 500. It's less likely that any of these are going to look similar. You could do that with the location also, or whatever. Or if you wanted to use this for something like the scale, where you want to select a specific range, you can use a map range node, plug that into the value, and then this into the scale. And you can just select the minimum and maximum values you want and use the 2min and 2maximum. So if you want the minimum value to be 1 and the maximum value to be like 50 or something like that, you can do that. And you'll be able to notice that some of them look a little bigger, some of them have a lot more fine detail like that. So one other thing that happens when you realize is things calculate at different speeds. So we can actually check the speed if we go up over here to overlays and choose timings. You can see that there's a time on each node. And at the very end, this is like the total time it'll take to like calculate. Now let's make this a little more intense. We'll turn this up a lot higher. You can see it's like 4.3 milliseconds right now. And as soon as we realize the instances, this jumps up quite a bit, up to 11 from 4. So when you realize the instances, it will slow things down quite a bit. So I recommend only realizing instances if it's something that you need to do. Let's turn this down a lot lower now. One other thing that changes when you realize instances is if you're trying to distribute points onto instances. Let's bring in a distribute points on faces right here. And I want to distribute points onto the instances right here. So I'm just going to drop this in. You can see we have a bunch of points. And I want to join these points with the instances over here. So I'm just going to mute this set position, grab the instances like that. And I'm going to turn the density down quite a bit. So one thing you will notice, especially when I turn it down pretty low, is that again, just like the materials, when you distribute points, it's going to distribute them on the same spot on each of these cubes right here. On each instance, they're in the same exact spot. As soon as you realize it, that won't be the case anymore. You can turn this up a little higher. So it'll treat all of the instances like one object instead of like a whole bunch of copies of a single object like that. So let's make that cool fractal shape now. So we're going to start off not with the group input, but with a cone. So I'll add in a cone right here. And I'm going to turn the verts down all the way to 3. So we have this object that has 4 points now. And I'll change the depth to 1.5. So I'll take an instance on points, drop that in right here. And what I'm going to instance onto it is itself, like that. So now we have this shape right here. And I want to basically do this over and over again. Instead of making a whole bunch of instance on points like this, and then feeding it in like that over and over again, I'm going to make a group. So you can do this by selecting whatever nodes you want in the group. In this case, it's just a single node, and you can hit Control G. So now we're inside of the group. You can exit with this arrow right here. You can go back inside by hitting Tab. You can also exit and enter by just selecting the, the group input or output and hitting Tab. You can like toggle it like that. You can hit N over here or drag this arrow out to open up the side panel. This is where you have access to all of the inputs and outputs. So I don't need all of these options on the outside. So I can delete some. I'll delete the selection, pick instance, delete everything except for these 3. I also want the points and the instances and the scale to be sent out over here. So I'm actually going to change the scale to a float. So it's just one value. Now on the outside, this is set to 0, so I'll turn it back to 1. And I'll drag the instances over here, and I'll drag the scale over here too. And I want to rename these to match the input over here. So I'll change this one to points, just double click and rename it, or you can type it in down here. I hit Tab to exit, and this is what we have on the outside. So we should now be able to just drag this over here and hook everything up. To lazy connect like I'm doing, you can hold Alt, right click and drag like that. We might just have to change this to something smaller later because I don't want any of them to be overlapping like that. So I'll turn it to 0.5 like that. but I want these to be scaled up a little bit. So at the very end, we'll add a scale elements right here, and I'll set it to 2. So now they're touching and they're working fine. Another way you can connect nodes quicker is, I'll duplicate this over. If they have the same names over here, so you know this is going directly into points, it has the same name, you can select 2 and hit F, and it will connect them up like that. This only works if they have the same names as far as I know, and it will work with multiple nodes too. So I'll just drag a few more in here. We'll bring this up to about 6, and now with all these selected, I'll just hit F, and it will fill all of them in like that. You can see every time we add one of these groups in, it's iterating and making smaller and smaller shapes. One other thing you should also know about is if you change something inside one of these, it will affect every single group. These are all like copies of each other. And if you want them to be individual, you just have to hit this button right here, and that will make it a single user copy. You can tell that there are 6 of these because it says 6. So if you click that, these will go to 5, and this one will be a new different one. If you change things in here, it will be unique. But I don't want to do that, so I'm going to hit Control Z until it goes back. One limitation with doing this is that it only works for up to 6 node groups, I believe. And this just has to do with like recursive instancing like we're doing here. If you add a 7th one, let me save this real quick in case it crashes. If you add a 7th one right here, it's not going to work. And as far as I know, the only way to fix it is by realizing. So I'll add a realize instances in here. We can pop that in at the very end, and visually nothing will change. But, you know, this will add some time to the very end. It will make it take a little longer, which is unfortunate. So if we use the 7th one now, this will actually work. We actually get some, some finer detail in here. And as far as I know, you can add as many as you want as long as you're realizing them. You just have to be careful because every time you add this, it gets heavier and heavier on your computer. You can see up here in the spreadsheet, it'll count all of the vertices that we're using. And if I add one more, it gets quite a bit bigger. It gets big really fast. So you can also change what shape you're using in here. I just recommend that maybe you mute some of these before you change the shape, because every other shape is going to have more verts than this, so it's going to be heavier on your computer. So I could, replace this with something like an icosphere and plug it in right here. And we might have to adjust the scaling at the end. I'll just set this to 1. And now we can just start unmuting these one at a time to see how far we can actually go. It's already getting kind of slow when we do this. Let's see if we can add one more without it crashing. So you can make some pretty interesting shapes using this method. All right, that's it for this one. I'm planning on making a few more videos about geometry nodes for beginners, so subscribe if you don't want to miss that. I also have a playlist of all of my geometry nodes videos for those who are interested. I'd like to thank my patrons for their support, and I'd like to thank you for watching. Have a good one.